Welcome to another episode of Thermodynamics. Today we're going to talk about how heat will move. Well, when you think about it, when you're going to stab a hot poker into a fire or try to make s'mores, the iron will get hotter and hotter, and eventually the heat will reach your hand and your hand will start to feel hot. When you bring your hand next to the fire, your hand will probably feel warm, even when you touch nothing else. If you hold your hand on top of the fire, your hand will also feel hot. In fact, you might even feel some sort of hot wind that rises from underneath your hand, which makes your hand feel even hotter. Think about it. Why do you feel even hotter when your hand is on top of the fire compared to something near the fire? What happens to the hot wind? Before we talk about that, let's mention the different methods of heat transfer quickly. For example, the heat traveling through the poker will pass through all the molecules or atoms in the poker, and this form of gradual transfer is called conduction, and a poker or iron is a good conductor of heat. When you put your hand near the fire, the heat is emitted and travels directly towards your hand. In fact, the heat will radiate in all directions, which means it's called radiation. The last form is called convection, where hot air from the fire will rise and colder air will sink into the fire. This is why you might feel a hot wind. Let's dive into convection in a little more detail. We saw last lesson that the hotter things will expand and colder things will contract. Their weight, however, will remain the same, and only their molecular spacing increased, which means that the density of hotter things is less than the density of colder things. And because denser things sink, while less dense objects rise or float, hot air will rise and cold air will cool. This also applies to liquids. When hotter things reach the top, they cool down, and the cold things heat up when it reaches the bottom, and so the cycle will repeat itself. Let's do an experiment regarding convection. We'll add some vinegar to a small cup of cold water before placing it in a larger tub. This larger tub is filled with hot water, and the water level will reach the vinegar but will not reach the cold water. As a result, the vinegar will be heated but the water will not, and so we observe a convection effect with the vinegar. At first the water seems clear, and there's a lot of vinegar on the bottom. But as time progresses, notice that the heated vinegar will make the water murkier, and at the end there is less vinegar on the bottom compared to the original. The vinegar got heated, and some of it floated up to the surface and mixed with the water, which made it murkier, and there will be less vinegar on the bottom as a result. Thank you